So broad category of functional domains, right? I think in the previous topics, we also touched upon what are the various functional domains which is applicable or which is available. Yeah. So here we take one example and try to discuss what that functional domain is, focusing on or trying to add value to the product development. So the example what we take is the design engineering, yeah, in the functional domain. So here, if you are a mechanical engineer working in the design engineering team, yeah, so you can also call yourself as a mechanical design engineer, yeah. So your objective is to design or give a solution or a blueprint of a particular system through the application of engineering physics. So you use the engineering physics, okay, to develop the certain products. Yeah, say for example, you would also do a technical research, okay, to understand the functionality of a product and also to arrive at a solution, right? So basically, how do you arrive at the solution as a design engineer? Yeah, it's not like you have a problem and you provide a solution. It's not straightforward in most of the cases. Of course, yes, in certain cases you could have a straightforward solutions, but more often than not, you will end up in situations wherein you will have multiple ways or multiple directions where your solution can travel. Yeah, say for example, for a particular objective, you can also have 4 to 5 solutions possible, right? And I think generating a solution is very important, yeah, for a design engineer, and he also uses a brainstorming technique. He or she uses a brainstorming technique to arrive at a lot of conceptual solutions. So he or she brainstorms the requirements from the customers or the need from the customers, yeah, and then try to arrive at a different solutions or different ways to achieve the objective, yeah, and then you select on which idea or which solution is cost effective, is quality effective, yeah, and then you arrive at certain solution, yeah. So basically the design engineers, they design the concept, they simulate the working, develop the prototype, and test it. Okay, so the responsibility of a design engineer does not end the moment you give the design to the next team. Yeah, because it's a closely knit working environment where it could be highly iterative. You work on the design concepts, you select the design concept, whichever is making good sense based on engineering judgments, and this design has to be validated because you would have designed it based on certain assumptions. So this design has to be validated through simulation, okay, and in the simulation you can again get into an iterative mode if the objective is not met. Say for example, if you are working on a internal combustion engine where you are working objective is to improve the efficiency by 2%, just an example, right? So you can have multiple solutions to it, yeah. So you simulate your solution and see if you are achieving that delta of efficiency what you intend to achieve, right? And of course when you do the simulation you will also consider a lot of assumptions, so it's kind of a bit far from a real world environment. So you try to make a simulation as closer to a real world application or real world environment. Yeah, so it's very important for a simulation engineer or a design engineer working in the simulation team to make sure all the important physics of the problems is captured there. Yeah, so this is very important. And then you provide a technical solution or technical go or no go. Now, once you also simulate it, yeah, you you send the feedback to the design team, and then the design team comes with a final development drawing. So this development drawing is like an engineering drawing where it has a bill of materials, where it has various views. Yeah, or it could also be CAD drawings for that matter. Yeah, or it could be 3D for that matter, 3D models. Okay, and then you develop the prototype. So once you develop the prototype, you have to ensure the functionality is met by doing a testing. So you could also do a functional testing, and you could also do a safety testing to make sure it's pretty safe for the end users. Yeah, so you basically test it on a variety of mechanical systems, or you test it on a different test rigs. Yeah, and you derive the product characteristics or the working characteristics of the particular product. Okay, now design engineers use a variety of tools. Say for example, if you wanted to release a drawing, right, the first thing which is also very important for the design engineer is to visualize what is in her or in his thought process, right? So you use CAD tool. It's pretty normal to use CAD tool by the design engineers, yeah, to bring their imagination into a virtual world, so that you can show it to the customers, you can show it to the stakeholders, yeah, in terms of how their idea would look like, right? For example, there are a lot of commercial softwares available which people are using in terms of, say you can use AutoCAD or Creo, SolidWorks, Unigraphics, so on and so forth. Or you can also make use of certain software which is available as freeware. You can use it for free. Yeah. So as a design engineer, you would be working on these designs. The advantage of using a software is that you can easily make the changes and you can easily release a development drawing. So this entire process from idea thought process to the development drawing, it is very narrow because of this usage of CAD tools.